This next handout that is available on the website is talking about the characteristics of a polynomial function, also known as the key features. So it's these 8 different features that we would always want to talk about to say what are the key features of a polynomial function. I always like to start over here, the parent function, the end behavior, the zeros, the domain and range, which could happen, you could talk about anytime. And then over here, the turning point in these increasing and decreasing intervals. This is typically something that you're going to be getting from a graphing calculator. These 3, okay? But the rest of these would be things that we would do without a graphing calculator. So first of all, let's look at this parent as a parent function. This is a cubic. We can see that it's a 3rd degree polynomial. It happens to be a trinomial, 3 terms, but it's cubic. So the parent function, we say this is 3rd degree, meaning cubic. The parent function can be seen as y equals x cubed. And so it's some kind of transformation of that function, which has a general idea of this S curve. So that's the parent function. The end behavior, because this is a positive in front of it, has the same end behavior as the parent function, which is as x is looking to the left, so as x is approaching negative infinity, because as this is the x-axis, negative infinity is over here on the left. So I'm saying when you look to the left, what's happening to the function? Well, we can see here on the parent function, it's going down. To say going down, we say that the function is approaching negative infinity, because this being our f of x axis, it's going down to negative infinity. So as we look to the left, it's going down. We're saying as x goes to negative infinity, the function is going to negative infinity. And that just means down. X is, now we're going to look to the right. So as we look to the right, meaning as x goes to positive infinity, which is this direction here, we can see that the function and the parent function is going up. This one would have the same end behavior as the parent function. It's going up, which means it's going up this way, which is up to positive infinity. So the function is approaching positive infinity. It just means going up. So this one says look to the left, it's going down. Look to the right, it's going up. The zeros, well, that would come from us factoring this polynomial. And if we factored this, we can see that x comes out of it, and we have x squared plus 6x plus 8, which means this factor, I'm going to write it right below where it says zeros, x times x plus 4 times x plus 2. And that's the factorization, which helps us find the zeros, which are when x equals 0, x equals negative 4, and x equals negative 2. And those are our zeros. The range are what we think of as the y values, or how high and how low does this go. And again, if we look at our parent function, there's no jumps or holes or gaps or anything, and it goes down, down, down forever and up, up, up forever. So therefore, the range is all real numbers. The domain, as it is for all polynomials, the domain are the x, or the inputs, meaning the left, and how wide does this get. For all polynomial functions, the domain must be all real numbers, meaning there isn't anything you can't plug into this function. So all of this, these 5 key features, are done without the aid of a calculator. And now we take this information and we put it on the graph to help us. And we say we have a 0 at 0. We have a 0 at negative 4. 1, 2, 3, 4. We have a 0 at negative 2. There should be a scale on here. I didn't put a scale. So 1, 2, 3, 4, 5, 6, 7. This is negative 7. And 1, 2, 3, 4, 5, 6. This is positive 7. And that's all you need. Just give me one number on each of the axes, and that tells me what the value of each one of those lines is. So this is counting by ones. So we have a 0, 3 zeros. Okay. We have our end behavior. It says when we look to this side, it's going to go down. When we look to this side, it's going to go up. So now to fill in the rest of this, to give us a better idea of exactly what's going on, that's when we would turn to our calculator to help us at this point. And so first thing we want to do is we want to plug that equation into our calculator, which I have here. x cubed plus 6x plus 8x, and 6x squared. We graph it, and now it's graphing it. We go, oh, okay, I can see that there's a relative maximum and a relative minimum. So we're going to go to our calculator and do second calc relative maximum is number 4. We're going to go to the left of that maximum, that relative maximum, and hit enter. We're going to go to the right of that maximum, enter. Then we're going to put it somewhere near that maximum, and then it's going to tell us what that maximum is. And it tells us that our maximum is, again, hard for you to read, but it says that our maximum is a negative 3.15. We have a relative maximum at negative 3.15, comma 3.08. And so that is a coordinate. I'm going to put that in here. Negative 3.15, a little bit, and then we're going to go up 1, 2, 3, and a little bit more. And there's my relative maximum. So I know that it's going to go up, and then it's going to turn down, okay? Then we have a relative minimum. So on my calculator, I go second calc relative minimum, which is a 3. It says go to the left, hit enter, go to the right of that, hit enter, kind of go somewhere near it and hit enter. And it tells us that our relative min, so I'm writing relative minimum, is negative 0.85 and negative 3.08. Negative 3.08. What's interesting, our relative maximum was at positive 3.08 and our minimum. That's an interesting idea in the function. So here we have negative 0.85, which is just to the right of negative 1. And we're going to go down 1, 2, 3, and a tiny bit more. And then we have it going down to this minimum and then back up again. And we have the general idea of our function. Now, increasing and decreasing intervals, it's increasing all the way, starting from way over to the far far left, and so we've got from negative infinity all the way to our maximum, and our maximum was at x equals negative 3.15. This is an interval. This is not a point. This is saying from the x values of negative infinity to negative 3.5, it's increasing. It also is increasing, so I put a union symbol like this. It's also increasing from this relative minimum, which starts at x equals negative 0.85 and goes forever, meaning all the way through positive infinity. And those are my two intervals of increase. Decreasing interval would be from a maximum down to a minimum here. So we have from the x value of the maximum, negative 3.15, to the x value of the minimum, negative 0.85. And there's your relative minimum. So now, looking at this chart, these are all the characteristics or key features of a polynomial function. Again, the parent function, end behaviors, zeros, domain and range, all of those 5, we should be able to do without the aid of a calculator. Right now, for the turning points, these are also known as the vertices. Okay, the vertices. This is something right now we need a graphing calculator for. Okay, you take calculus class and then we'll be able to do that without a graphing calculator. But those are the key features of a function.